Titan is the only other place with liquid on the surface. Titan is the largest moon of Saturn and the second largest in the solar system, bigger than the planet Mercury. It is the only moon with a proper atmosphere, and that atmosphere is thick. At the surface, the pressure is about 1.5 times Earth's, and like ours, it is mostly nitrogen. Under that air, there are seas. Radar from Cassini mapped them, mostly near the North Pole, and the largest is about the size of the Caspian. They are not water. At 94 Kelvin, water is bedrock, and the substances that behave like water at that temperature are methane and ethane, which on Earth are natural gas. So Titan has a full cycle of liquid, and it works the way ours does. Methane evaporates from the seas, forms clouds, and falls as rain. It collects into rivers, and the rivers cut valleys and carry material and build deltas where they reach the sea. Radar images show branching river networks that any geologist would recognize instantly, except that the bedrock they cut is ice and the fluid is fuel. The rain is rare and heavy. Titan's drops are larger than ours and fall more slowly through the thick air, in gentle, low gravity. Away from the poles it is dry, and there are vast fields of dunes running around the equator, hundreds of kilometers long. The sand in them is not mineral sand. It is grains of solid organic material that formed high in the atmosphere, drifted down and collected. In 2005, the Huygens probe landed there, the most distant landing ever made. Its photographs show a flat plain of rounded pebbles, rounded the way river stones are rounded, sitting on ground that instruments found to be damp. On Titan, you could fly by flapping your arms. This one sounds like a joke, and it is a straightforward consequence of two numbers. Titan's surface gravity is about 1/7 of Earth's, close to our moon's. Its atmosphere at the surface is about 4 times denser than the air you are breathing, because it is cold and cold gas is compact. Lift depends on the density of the air you push against. Weight depends on gravity. On Titan, the air is 4 times better at holding you up, and you weigh 1/7 as much. Put those together, and the requirement for human-powered flight drops by a factor of around 30. Engineers have run the calculation properly, and the answer is the same each time. A person, wearing a pair of wings of quite modest size, could take off and stay up by flapping. Not gliding. Flapping. Like a bird. You would need a great deal else. It is 94 Kelvin outside, and the air has no oxygen in it at all, so you would need a suit and something to breathe. But you would not need a pressure suit of the kind worn in vacuum, because the pressure outside is close to comfortable. It is the only surface in the solar system where a human being could move around in ordinary clothing, plus a coat and a mask, and it is the only one where the sky would hold you up.